the role of data analytics. So basically, it is the process of examining, cleaning, transforming, modeling of the data with the information that we want to retrieve from that particular data, that we can able to take some decisions, important decision from that. Data analytics has several other aspects also. We can find out the various insights from the data, various statistical information from the data, that mean, median, mode, some correlations between them, standard deviation, variance. We can find out from the data. So before starting with this, we need to understand what are the basic steps that we can follow in the data analytics. So basically, there are main 6 steps. First, we need to have some data that in the format of some Excel files, some Word files, some text data that we need to assemble, that can be able to use as or manipulate with the help of some data analytics tool. So data collection is the main part in which we have to find out the main attributes for which we need to collect the data as per the different problems. After that, once we are getting, we can collect the data from any different modes. For example, we can prepare a Google Sheet, we can prepare an Excel sheet. So number of things are there. We can get the data from the app or some other software. So first thing is that we need to have defined some set of attributes and collect the data from different sources, so that we can able to analyze that one. The next thing is that if we have the data, now, if you want to process it, we need to first clean that data, because there are number of errors, number of duplicates, irrelevant data, missing data, not in the particular format. So data can be used, not able to use with the particular system. So we need to do data cleaning aspect. That next is the once we have collected the data and clean our data, then we start with the data exploration afterwards. Then we can start with the data exploration. This we can do with the some tools in which we can able to visualize our data. We can see what data we have, whatever the facts and figure we are getting from that. Then properly we will do the analysis of that data, and we will get all the results as per the demand of your research article or your research process. In the last, we will go with the visualization part, and after that, we will find out what decision we can make up from that data analysis that we have done. So these are the initial steps that we need to perform whenever we want to do this kind of data analysis. And we have number of tools that can be used for the data analytics parts. We have Python, that is a particularly coding language in which we can able to do any kind of coding in the ML, DL, data analytics, everything is possible. Then another tool that is very, very good at the moment, that is the R Studio, R software, that can also be used for the data analytics part. The other tools that I have listed is particularly used for the social sciences group. For example, we have a SPSS, we have some other data analytics tool like eViews, NBO. We have many more. But before learning these data types of tool, we need to understand that in which stream, which area we are working on. Preferably, I'm from the computer science area, so I will work on the Python here. All the tools are very good, and we need to do some practice. Some of them are free, some of them are paid. Python and R is totally free software that we can use for the data analytics part. But SPSS, EView, and NBO, they are not the free. They are having some trial version, and we can use and purchase our license as per your requirement. So today we will focus on Python only. It is a free open source tool that we can use for any other. And if we see in the context of programming, so it is a very easy language. Anyone can start beginning with the Python. So it is a one-line code for the various functions. So it is not that much difficult that we will hesitate to work on Python. So basically, we will start the data analysis today with the help of Python. And for this, I want to share my Jupyter Notebook first. My Jupyter Notebook is visible to all of you. Sir, my screen is available.
Yes, ma'am.
Yes, ma'am.
Okay. So today we will do one project related to the data analytics. And first, before starting with this, I'm briefing about my project. So basically, I have this healthcare project in which we are doing some healthcare analytics. And with the help of Python software, we will do all the tasks and we will learn number of points in this. And we will also understand how to do data analytics using Python. So first, basically, this particular problem is related with the health chem data. So we have organized some of the health chem. I have basically taken the data from the Google, and this is the Excel sheet that I'm having. I'm exploring it. So we are having these attributes here: patient ID, healthcare camp ID, donation, and health score. So basically, this is the data that we have collected. This is the first camp. After that, we have second healthcare camp. So same sort of data we have. So number of camps have taken care under this. So we have taken total 3 camps. So in the third one, we have the patient ID, healthcare ID, camp day ID, number of stalls visited, last visited number. So this is the data that we have in the analysis, and healthcare camp detail. So this is the healthcare camp detail. So camp ID, camp started on, camp ended on, and category-wise description of the patients as well. So this is the attributes that I said in the starting. For the data collection, we need some set of attributes. These are the attributes. So we have defined our own. We can define our own attributes as per your problems whenever you are going for the data collection task. So I have already collected this data from the Google. You can also search and you can find out. I will share my this code notebook as well as the data sheets as well. So now first we will understand what is this data. For this, I am using the Jupyter Notebook. Jupyter Notebook is a Python IDE. It is a very useful and easy to do work on it. For this, we need to install the Anaconda version. I'm just writing over here. Just wait. I'm using Jupyter Notebook as IDE for Python. And for this, we need Anaconda software that we can download from internet, or I will also share the link from where we can download it. Other IDEs we can also use, that is the PyCharm. If you are having PyCharm, no need to install the Anaconda as well, Spider, VS Code. These are the some other IDEs that we can use with the Python. So once we understand this, that we need a particular software, and that software we are using here with the Python. And for this, if you are using Jupyter Notebook, we need a Python software that we need to install the Python using Anaconda. And if you are not having any of these, and if you don't want to install as well, then we have a Colab option. Then we can go with the Google Colab. Google Colab. These are the multiple options in which we can use Python and with the various IDEs. So once clear with that, we will go with the code now. So again, we will start with the code. So before starting this, just wait. Before starting this, we need to understand these libraries that we have used here. So first of all, I have used one library, NumPy, Pandas, Matplotlib, and stats module, and the Seaborn, and warnings that we want to. So let's discuss one by one about these libraries. NumPy, Pandas, Matplotlib, stats modules, Seaborn, Akal. These are the basic libraries that we are going to use under this project. So we will understand we are using NumPy for the basic calculations. That NumPy is what? Numerical Python. So with this package, we have a number of things. We can define the array, we can do the major calculations, we can find out the sum, min, max, all these kind of categories is available under the NumPy. So that's why we are calling this library in this project. Next one is the Pandas. Pandas is the basic library for the data analytics that we are using in Python. It is help in creating the data frames. It will convert the large file into the form of data frames. So that data frame will help us to locate and visualize our data in Python in the form of tabular data. So matplotlib is the library for the visualization, and for the statistical features like correlation, t-test, something else that we need this module for that. And C1 is the advanced version of the graphics, so we need that one too with the help of matplotlib also. And some of the features like clustering or k-means, we need the sklearn as well. So these are the basic libraries that we need for this project. For importing, first of all, we need to install that one. So I'm also writing the command here in which we can able to install this. You just need to write pip install library name. You just need to do this. Pip install library name. If it is NumPy, you need to write NumPy. And the latest version of the NumPy, Pandas, Matplotlib, stat modules will be installed in your system. So first we will go with this NumPy, Pandas, Matplotlib, and this is the object notation. If you want to use this one, we need to add as an object. So after that, for some of the metrics that we have used in the standard statistic, that is logistic regression also. So we are using the sklearn library in this. So first of all, that the data I have shown here, the first part, second part, and the third healthcare camp. So I'm showing the data. So we are including that data in our Python system with the help of Pandas library. So we are creating data frames here. So basically we are creating the, I hope if you are not familiar with the Python, or if you want to understand why we have written this one, so you can ask me anytime during the session. So I'm explaining this. This is the function pt.read underscore CSV. So this function is written in the pandas. So this is used whenever we have a data in the form of any Excel sheet or CSV file. So we need to call this function pt.read underscore CSV. So when you call this function, the next parameter that is in the brackets is the path. Path means where it is stored. See here, this is my folder, healthcare analytics. Under this healthcare analytics, these are my files. And these files I'm using in my project. So the extension is CSV. This is the particular file name. So this is the path here written, the root folder. And after that, we have healthcare analytics. Then we have untitled folder. Then we have our file. So we need to write the particular path here. See, so we need to write the particular path here. So once we did that, so we understand that this particular file is available here. So when you run this one, this particular file will be available within the dataset will be shown. So this, we have three files, three Excel files. That's why I write this code 3 times for the file 1, 2, and 3. So once done with this, the next thing that we will check. We will check that whatever the data frame we have added here is available or not, or shown or not. For this purpose, we need to write data frame name, that is the df1 we have written here. The next we have df1.head. Head is a function in which we can able to visualize the upper 5 rows of our data. The upper 5 rows of our data. So if you write here 5, 10, so it will provide you more number of rows. Otherwise, by default, it will show the top 5 rows. So all columns and top 5 rows. So this is the data displayed when we run with this df.head function. Okay. So we have chosen this for the all the three data frames, data frame 1, data frame 2, and data frame 3. So we have seen that we have retrieved all the columns with the top 5 rows under this. So once we're done with this, we will see how many rows and columns we do have in our data that we have just imported in the form of data frame. So for this, we need to call data frame dot shape. First function we done data frame dot head. Next function we are doing data frame dot shape. So shape function will return the number of rows and columns from our data that we have stored in the Excel sheet. So we did this for all the three sheets. So in the first sheet, we have retrieved with the 6218 number of rows and 5 columns. So in the second one, we have 7819, 7819 rows and 3 columns. And in the last one, we have 6515 rows and 4 columns. So after we have seen that we have imported or uploaded our data frame in the format data in the form of data frame. So now we will check, because before analyzing, we have to do some cleaning part. That is the second stage we have shown in the PPT. That second stage, wait. That's the second stage in the PPT, data cleaning. We have data, we imported our data. Now the next thing we will do is the data cleaning. Why we need cleaning? To remove errors, unformatted data, missing data, duplicate data. All these things we are going to clean in the data cleaning part. So all the features are not necessary that we are going to follow in every sheet or every data set. It depends. Whatever the form of data we have, do we need any duplication removal? Do we need any missing value removal? Do we need to do any fill any process? So for this, we need to analyze, we need to see the data. On the basis of that, we will able to decide. So in this, we are going to drop few columns here. For this, I am using the function drop. Why I am using drop this column? So see here in the first one, we have column ID 1, 2, 3, and 4. And in the data, we are having, see, this is the missing value in the data 1. Similarly, some few missing values as well. This is the another missing value that we have. This one, the another missing value. So it is not good to have missing data if we have in this. So what we are going to do, we are checking the number of missing data and we are going to drop it. For this, I'm writing a code df1, the data set we want to do the changes, data set name dot drop. Then we need to put brackets over here. Under the brackets, we are providing the column names. Column name is donation and unnamed. So we also provided the axis 0 or 1, 1 for the row and 1 for the column, because we want to do all the changes in our data set as well. So that's why we have written a keyword in place is equal to true. Otherwise, the changes will be temporary mode, not stored in the data set. So that's why we have written this line df1, df is your data frame dot drop. Why we are dropping one column, and that column is the donation and unnamed. So these two columns are going to drop in the data frame 1. So similarly, in the data frame 3, the last visited number, it is empty one. So we are going to drop this one also. So data frame 3 dot drop last visited number, and same we have axis selected as 1 and the column that we want to delete as 1. So till now we have done to select the data in the form of data frame. We have checked the shape, we have checked the sample of the data. Now we are doing some other operations as well. So we are going to check out what is the mean value of the health score that we have retrieved by analysis of this data. So for this, I have created one empty list and I have created one counter here. This is the loop that I have did because it will check the throughout all the data set. So from the data frame 1, we are visualizing the health score, and I stand for the number of iterations it will do. For example, first time it is 0, then 1, then 2, then 3, and so up to the last column, up to the last row, sorry. So after that, we are comparing it with data frame health score dot mean value. So after mean, we are going to append the list or list. It means we are going to figure out the number of rows that came under this category. Means those health score is greater than the average score. It came under category 1. Other will classify in the category 2. So it's basically function in which we are finding out the health score of the patient, and we are comparing that those having greater than the average health score came under the 1 and other will came under the 2. So second, we will do the same thing with the data frame 2, and again we will do for the data frame 3. So in second, we again doing the same procedure. We are going to find out the average mean score for the data. Average mean score and analyze the data on the basis of that. The third one, we are checking the number of stalls visited is equal to 0. It means those come for the desk health checkup, but they are not visiting anywhere. We need to identify that one. So for this, I have written the score. So under this, what it will do, it will provide a loop in which it will check out the total number of rows from started from 0, and it will figure out the number of stalls visited by a particular person, and if it is equal to 0, it is appended in the 0, otherwise it will appended in the 1. So in this way, we are finding out these information that we can extract from the data set. So further, if we are calculating this system, we are implementing it in the data set as well. So we are doing adding a new column here. So what column we are going to add? The list that we have prepared yet. H1, H2 and H3. These are the three empty lists that we have created and prepared on the basis of the data set. So we are including the binary values associated with it. Binary values, why we said binary values? Because in binary, we are having only two values, 0 and 1. And we have prepared three lists, H1, H2 and H3. So on the basis of that, we are adding these three lists in our data set. We are adding these three lists in our data set. So by adding these three in our data set, we are able to find out how many are above the average health score or how many are not going to visited any of the stalls that came under this health camp. Okay, so after that, we are dropping some of the columns that we are not required under this. So what we are doing here in the data frame 1, drop health score, because we have figured out the 0 and 1 category on the basis of that. So now we are not needing it. So we are creating a copy of our data frame. So for this, what I did, df2 dot copy. So it means we are preserving the copy in the df1 dot copy. So we are keeping that data in the copied and we are dropping that one. Similarly, we are implementing the data frame 2 as well as the data frame 3. Okay, now after doing this, we are combining these three data. Earlier, we have the data in the form of three sheets, sheet 1, sheet 2, sheet 3, carrying the results of the health camp 1, 2, and 3. So now we are concatenating both. So first we are converted into the data frame and we are creating the copy of that. Now we are combining the three. So for this, we are using the pd.concat. In this pd.concat, we are passing the list that we want to concat, and we also need to provide on which manner we want to concat. We want to add the row-wise entry. So for this, we also define the new index for the new data frame that we have defined after the combining of all these three, that is the DF. So we have dropped the initial index that we have. See, we have this index 0, 1, 2, 3, 4, 0, 1, 2, 3. So we are dropping that initial one. So we are creating a new one. So basically, this will be the next data frame that we have created after merging of these three. So till now we have taken three data sets. We are using this data set into the data frame. We are dropping some of the columns that is not required. We are converting the data in the binary form as per our the requirement. So after that, we are concatenating this and make a new DF data frame. So we are dividing the data because I'm using some of the clustering operations as well in this. So that's why I have segregated data in the training and testing phase also. So for this, I have divided some of the part of our data in the training as well and some of the part of the testing as well. So in this, I am displaying the training part that we have shown in our data frame, that we have selected the partition of this data frame. So this is the data set that we have used for in our training part. So this is it means the number of columns remains same, but the number of rows is divided in the two categories, training and testing phase. Okay, so for this, we have concatenating. Earlier, I have used one function for the concatenate. In Python, we have three main functions that we need to join the sum files. One is the concatenate that is shown here. The second one is the merge function and third one is the join. I'm using two of them. The next one is the pd.merge. This function dot merge, what it will do, it will combine the results of two different arrays, two different data frames, two different files. And we need to define, this is the output file data frame df. This is the file from where we need to collect the data. And this is the parameter on the which we are going to merge these files. So what we are doing here, we want to do the merge key on the patient ID and the health chem ID. And what kind of merge we are using? We are implementing the inner join here. That's why how is equal to the inner join. If we are not using how or any other term, we are just preferring merge df or train. We need at least two parameter here. So by default, it will check out the number one, that is the unique ID. It will perform on that. And by default, how is equal to inner only. So this way, we are going to merge different data frames and prepare a new data frame from which we are able to do some analysis. So now a new data frame is available for our analysis. So earlier we started with the three. We do some calculations, we merge the data and we create a new data frame, that is the df dot new dot head. So for this, we have all the three data uh, all the health camps connected here. So do we have all the patient ID, healthcare ID? This is the joining. We have already written here. On the basis of this, we are joining this one. Then we have health score. On the basis of this health score, we recognize the binary value 0 or 1. And then we have registration date when we have calculating these variables on the basis of that. Okay. So after creating this new data frame, now we are going to check, is there any null value? Is there any null value? Null value is what? It is the missing value. Null value. Null value. It is the missing value. And sometimes we call it as NaN or NA value. NA is not a number. So these are treated as missing value, or we say there is no information under this cell. So it creates a number of problems when we are doing some analysis part. So if we don't want to have these kind of problems. So we are doing the cleaning part here. So first we need to check is null. Is null is the function which is used to check that do we have any null or missing value in our data frame. So data frame name is there, dot operator, then we are using is null. So when you run this one, it will show the number of columns where we have a null value. So dot sum dot sum will find out the total count. So in this C, patient ID we have zero null value. The healthcare ID we have zero null value. But in the health score, we have 14334. This is the number where we have null values. And for binary that we have just created 0 and 1 data, it is 0 null value. For the registration date, there are 301 entries where we are having no registration date. So similarly, if you have any data set, write the data set name, write is null, call the sum function. It will provide you in this top number of columns where we have missing value. So on the basis of that, if it is a large number, we can decide what we need to do. Otherwise, we can proceed with the other part. So now, if we have any null value, now we will going to drop it. So for this, we are using the function drop NA. We are using the function drop NA. Drop NA will do, it will delete all the null values from the data set that we have just created and analyze for the missing values. So data frame name is df underscore new. This is the data frame name. Drop NA is the function. In the bracket, we have to define drop row wise, and we have to set the reset index that we, once the data is related, we will provide a new index there. So from this, all the NA values will be dropped from the dataset. Again, for the confirmation sake, we will rerun this command. We will see that now we are having no NA values that we have earlier. We have seen that 14334, it is the number where we have missing value. But after removing or dropping NA, we are not visualizing any missing value, so that it confirms us that we can proceed with the further analysis part here. Okay, so again, in the data, we are having some of the date functions as well in our data set. So date functions. So everybody know that whenever we are using some functions, like we have to put on the joining date, date of birth, experience, so program date. So we need to add one date function as well. So in the computer science, this date function is has various part. We have date, we have day, we have month, we have year. So whenever we are taking data from multiple resources for number of persons, so it may be possible that there may be different formats for the date, because we have the different criteria. We can do the slash, we can point the dot here. So if you have this kind of problem in our data set, so the simple solution for this, that we need to convert that data into one single format. So every time whenever you are having any data, see here, this is the date, this is the date. We are having date hyphen month hyphen year. It may be possible that some of the files where we have multiple formats for the data as well. So we need to clean that. So we are going to clean under this code. So first of all, pd dot to underscore date time. So this function will convert any string, any raw data into the particular date and time value. For this, this is the column where we want to store the result. And format, we are defining the format here: percentage day, percentage month, percentage year. So this is the format, and afterwards the date will be available in this format only, whatever the initial is. So it will be converted into this format only. So we can extract the year, we can extract the month, we can extract the number of days, we can calculate the duration. If we are having the data in the format of days, we can do any kind of analysis or the time series analysis in this if we have the data that is available in the format of date. Okay. So next, what we are doing here, we are extracting the month part from the date. We are not doing any manual thing. We just want to find out the month. So for this, we are using this date. Input is the date. We are calculating the month from this. So for this, I'm writing this function. I have created one empty list for the month. From the first row to the last row, df dot shape means 0 means first and df dot shape up to last means the last value. So what we are doing? We are doing date I. It means that particular date dot month that is going to append in list M. So after this, we are able to see that the month is added. The month is added. For example, if it is February, month will be 2. Second month, if it is January, month will be 1. So on the basis of date, we have extracted the month value. Okay. So because we have extracted the month value, so we don't need date anymore. So we are going to drop the date column, the date column from this. So after that, taking important columns only, because as much as data we have, we will do some kind of computation and calculations as well. So that much time is required. If we have more data, more calculation, more time will be required. If we have only limited and to the point context, then it is fast and easy to implement and do the task. So that's why we will drop all the unnecessary columns that is not required for our data. So for this, we are using the tf.drop. Okay. So if you want to access your data, so we are having the function ilog. Ilog, for this, we have to provide the value from where we need to extract that particular data, right? So this first for the rows and second for the columns. The blank for rows, so I'm showing here. Just wait. So see, it is written blank. And after that, there is a comma and 2 colon minus 1. What does it mean? So for first, it means that all rows, because first variable before the comma is for the rows and second variable is for the columns. So we are using all the rows here. So for column, we need to start with the second one. We are not going to deal with the 0. It is for the header purpose. And we are also skipping the first one. And we are using till minus 1. Minus 1 is the last option. Minus 1 is the last option. That's why we are extracting the data from the data set using this slicing part. So for this, we are using the ilog function to access the data from the data frame. Again, we are checking the number of variables that we have in our data frame. Okay. So here we are transforming the data and we are calculating some of the useful things from the data that we have. So for this, we are implementing the standard scalar from the Keras. Sklearn, sorry. So standard function, we have defined one function. So this function will able to find out the scaled value from over the data and do some transformations from the data. So this CS class has two functions, base estimator and transformer mini. So for this, we are using one constructor here that is in the Python as well. So for this, self is the object of this class CS, and we are calling this function CS, that is the standard scalar. And standard scalar is here, copy with the mean and standard deviation. So this function will give us the mean and standard deviation from our data. This will provide the number of columns, and these are for empty at the moment. The next function we have used is the SK scalar model that we have used here. It will check out the model.fit function for all the rows and values. So after that, it will provide you the mean and variance. And in the transformation, we have transformed the data. And for this, we again check the number of rows and columns. So this function will be used later in the code for the analysis part. So for this, if we have this call month, it will provide you that particular month from the data that we have quoted here. Again, similarly, these functions as well, we will provide you the data that we need to do some kind of estimation as well. Okay, so after that, this is the same code that we have used here. This is the thing that we are going to distinguish or split the data into the two parts, X train, Y train, X test and Y test. So after that, we are calling here the standard scalar function for the input. We have providing the training size here we have providing the random state that we are going to use here. So once we are doing this, so first we are checking the number of parameters that is considered for the text and train. So these are the number of parameters. Both have the 6 columns, and this is the configuration for the rows 5751 in the train and 1918 for the testing. So the code that we have just done and the function that we have just prepared, from this we are going to call the logistic regression, that is providing you the basically a one straight line for the production of your model. So this function is used for the calling of the logistic regression. So after this, it will provide you the data that you have just used here. So it will provide you the prediction value. See here, LG is what logistic regression and score for the particular X and Y train. And after that, the average value we are getting here. This is the prediction value that we are getting here, 53382. And if you want to check what is inside this training and testing data, then again head function is used that we can able to visualize that what this training data is. So we are getting a sample data from this. Okay. Now, if you check converting registration date into date and time column that we have already done earlier, PD dot to date time. Same, we are converting the number of months. Okay. So in this, we are checking out the number of month, and we have given a one value where month is equal to 2. On the basis of that, it will provide you the logistic prediction, and it will also provide to the argmax the maximum value, and it provide you the accuracy score of this model. So this is the some simple logistic regression that we have just implemented in the Python. And there are some other terms that we can use in the Python, that, for example, we have a descriptive statistic. So before starting with this, just understand what is the basic terms that we have in our statistic. So a descriptive statistic is what we will get in the descriptive statistic. Descriptive statistic is what it will provide you the description of your data. It will provide and summarize your data. It will provide you the mean, median, mode values. It will provide you the dispersion of your data. It will provide you the range, variance, standard deviation from your data. And there are number of things that we are getting in the descriptive, but this code is one single line, right? Dot describe. This is the one single function that we are using here for descriptive analysis in the Python. So what I'm doing here, again, I'm using the data frame. We converted the file in the form of data frame. After that, I'm merging these files and converted into the single file. That is the health camp ID. On the basis of that, we are merging these one and converted into the single value, health camp detail TF. Okay. So after that, we are going to visualize the descriptive statistic of these three. So what we need, first underscore camp underscore descriptive underscore statistic. This is just a variable name. This is just a variable name. And this is the data frame name, first underscore camp underscore data. And when we call it dot describe, then it will provide you the descriptive analytics of the complete data set that is stored under this. Similarly, we have done with the second one. Similarly, we have done with the third one. So now, if you see this, this is the result that we have got from this. So I need to attend a call. I just want to mute for a second. I'm really sorry for the interruption. So let's continue with this. So we have a descriptive statistic that we have just received after running this code. So under this, see what we have. This is the total count in all the columns. After that, we are getting the mean value. We are getting the mean value of the column. See, why we have cleaned the data, we are getting NaN here. So what does it mean that we have a mean average is not a number? No, because there is some of the values that is not as per the parameter. So the system is not going to do any computation. So it will provide you the NaN value. So if you are not willing to get this kind of data and you want to get exact average value, so it's very much important to clean the data in proper format so that we are getting the exact result. So these results we are getting just because of one function dot describe. So we are getting the mean value, standard deviation, minimum value, quartile 1, that is the 25%, quartile 2, quartile 3. We are getting all the radiation ranges here also. We are getting the minimum and maximum value, and we are getting the mean and standard deviation as well. So similarly, we have received the statistic of the data set 1, data set 2, and data set 3. So we are concluding this one, the statistic value of the data set 1, 2, and 3. So we have just calculated, we have just written one more thing here. See, in this 3, we have just called the dot describe function. And in the last one, I have used one more function that is available in the statistical library that we have just imported in above. That is dot CORR. CORR. I'm highlighting this one. CORR. It is correlation. So what is correlation is? Correlation, it is a statistical measure that indicates the extent to which one or more variable fluctuate together. A positive correlation indicates that the variable increases or decreases together, while the negative correlation indicates that one variable is the other will be decreases. Means there is a inverse effect over that. So this is the correlation, and just we have calculated with one function dot CORR. So how we calculated it one? So this is just the variable name, first underscore camp underscore correlation, and this is the column name. This is the data frame name, and under this we are having two columns: donation and health score. Donation and health score. So we find out the correlation between these two columns. So we are getting this result. So correlation between that, we are getting this one value. Definitely, if donation is there, then the health score is also there. It means there is a relation between that the person is going to give some donation for this kind of word and feel healthy, and some affirmations at that end. So this is the correlation that provides us the relation between these two variables. Similarly, we have find it out the basic statistic, mean, median, and the standard deviation, and the quartile range, and also find out the correlation from this data analytics. Okay, we have four more things in that also. So see here, so we have some more operations that we have performed under this. So this is the t-test. So it is also having the some other understanding in the statistic. We have different kind of test, t-test, z-test, f-test. So I'm just implementing some of this test also here. For this, we have taken two sample from our data set. We have defined one function. That function we have defined with the name of t underscore t test underscore independent. And we have run this. See, we have run this one. This is just a function name that we have just defined. This is the name of the function that is already available in the Python. Stats dot t test underscore int. So this is the function name that we need to call when you want to perform the t-test. For this, we need to provide two parameters, sample1, sample2. And if there is any n value that we are going to test under this sample, so I am using here word omit. NaN policy is what? If there is any missing value, we are not including that one in our calculation, we are going to omit it. So this is the simple function that we are using for the t-test function. Similarly, we have created some other functions for the other regression problem, and normality test and the clustering test. So other function in the OLS regression, we have made the function SM, that is the stat module dot OLS. This is the function and provided the parameter that we are using here fit fit. After that, model summary. After that, model summary. So we are adding one constant value that we are providing in one variable x. On the basis of that, we are calculating the x and y fit value and finding out the regression line here. Similarly, other test is the we are going to run and check out the whatever the values we will receive after the running of these two. So after that, we are having the normality test. Normality test means because we are having a number of samples, a binomial normalized sample. So on the basis of that, we can check the normality of our data set. We can finding out at that also. We can do the clustering of our data set. We can use the standard scalar that we have used earlier, standard scalar dot fit transform drop DNA, drop NA. And we call here the K means we provide the number of clusters, random states, and data to be scaled. So under this, we are going to run this one. So see, when we run this, so what we get here? The t-test value after getting the results we are getting here. T-test between two camps for the health score. The t-test in and the results statistic is what? -80249. This is the value we get, and the p-value have the significance as the 1.095. So we can finding out that the t-test operation is performed with the help of this, and this t-test is called here. See, the t-test is called here. We have provided the two groups, group 1 and group 2. This is the function that we have just defined over here. This is the function. We called this function here because we need two parameters, sample 1 and sample 2. For sample 1, we have taken the group 1, and under group 1, we have taken the health score column only. And under sample 2, we have taken the group 2, second camp detail, and drop NA. So once we define the x and the sample values, then we need to call the function, and the function name is that t test independent, and then we need to define the sample, first sample and the second sample. And once you run with this, you are getting the values of the t test here. The next we have done here is the regression, OLS regression. So OLS regression, we have just defined this one here, and we called here this. So in this regression, we have just called, we have defined the variables for x and y. Because regression on the same data model, within the same model, we are going to find out the production line. So we are taking only one sample here, that is the third data set. So we are putting the x and y variables here. So x and y variables, we are checking the number of stalls and the last stall visited. So we are checking the number of stall and last stall, we are finding the relation between that. And for this, we are calling the OLS underscore regression. This is the function that we have just defined. And under this, we have called this sm.ols. So when you run this, you see, you can get this value, OLS regression of last stall visited on the number of stall visited results. So dependent variables is this. Model called is the OLS. Method is the least square. Date and time when we have used it. The number of observation is this. Covariation relation is there. Hello, am I audible? I'm really sorry for the disturbance. Actually, because it is a working time, so we have a being ahead, I have to address number of the queries as well as here also. So I'm really sorry for that. So we are having the relationship here. So we are finding out this for the R squared and adjacent R squared, the F statistic value, the probabilistic value. So these are the values we are getting here. So after this, we are finding out the coefficient of the standard error, the validity value, the p value. We are all getting of the values under this with the help of this one function. So learning Python for the statistical data analysis is not very tough part. We know that in the machine learning and deep learning, we have to learn lots of things. But if we are using this package just for the sake of data analysis, so we need to do have practice 15 to 20 days. You can able to analyze after that, and you can take the help of AI tool as well for this. So it is not an easy. So I just recommend this tool because it is free of cost. We can do any kind of data. There is no limit on the data size as well. So let's move further. So I have done the normality test as well here. Yes, normality test. Normalization test, we have just called the normal test and we provided the data and same policy we have used. So this is the just function. You need to learn the function and you can run that one. So similarly, k-means clustering we can also use. This is the same code that we have run earlier one. So apart from this, because till now we are just getting out the summary value for the numerical figures as well. We get the correlation, we get the descriptive statistic, we get the mean values, average values, and all that. So let's do some visualization part also in this. So for visualization, because we will able to find out the graph and figures in the statistic part also. So for this, we are using two libraries here, the matplotlib.pyplot as PLT and the cbon as CNS for this as well. So for this, the CNS.set, this is the style that we have just used. CNS.set is the style is the white grid. It means whenever we are getting the graph, we are getting the graph style is this line. So next parameter is that plt.figure. Plt.figure, this particular line is used to finding out or defining the size of figure that we want to display. It is means the length and breadth of the figure. So it is in the inch, centimeters as well. So it will provide you the figure size. So this is the function that we are going to use here, the hist plot. I'm showing you what is hist plot. Hist plot. This is the function. It is the histogram. Histogram is the special statistical graph in which we are able to visualize the data on the basis of the frequency parameters. For example, if we have category 1 and we are having 3 samples here, so it will provide you the frequency 3. So this is the histogram. It is not providing you the highest or lowest value, mean or maximum. It will provide you the statistical detail of the graph. And for this, we need to call this function hist plot. We need to call this function, just wait. We need to call this function hist plot. And under this, we have data frame that we have just defined data frame 1. And we have to define, we want to draw the histogram of which row, which column, which data frame. So DF is the data frame that we are using here, and health score is the column name that we are using here. And why we are using drop NA, the same concept, because during plot teaching time, we don't want that any misvalue, any misinterpretation that we available, so that our data or results will be not as per the appropriate one. So if you want to add the title in your graph, just write plt.title. It will provide you the title at the top of the graph that we will get. So after that, we have plt.x label, because in the plot we have x and y axis. And if you write something on the x-axis and write something on y-axis, then you need to write the x label and y label. For x label, we have put the health score, and for y label, we have put the frequency. So after that, we provide the plt.show. So this is the code in which we can draw a one histogram from our data frame. So similarly, we are having some other graphs as well. So first we will see the histogram. So this is the histogram. This is the title of the histogram, x-axis, y-axis. This is the average, this is the values that we have. in our data frame. So this is the total range, and this particular graph shown the type of graphs that we have in this. Just wait one. Hello. The graph is plotted here now. So this is the histogram. Basically, all the frequencies are plotted as per the graph shown. So next one, we have a scattered plot. So scattered plot in which we are having a number of dots that is scattered over here. So the plots are available in the scattered format. So again, we have the figure size. Then we have the SNS dot scattered plot. We have the duration. So scattered plot, we need two values. We need two variables here. So that's why we have used the X and Y here. So we are plotting the graph between the two columns, donation and the health score. So under this, we have the data frame DF1. So again, we have the title X label and Y label dot show. So this is the scattered plot that we have just plotted on the basis of health score and donation using this graph. So this is the statistical value because this plots indicates the area that is maximum covered and the number of points under this that we can move for the clustering part, and we can plot multiple variables in the scatter plot as well. So next one is the bar plot, is the simple plot in which we are having the X and Y axis on the basis of data. So plotting this, we need to plot here the average number of stalls visited in the third health camp. So I have just plotted, just framed my question as per the requirement. You can frame your own questions as well, and the code for that question will be changed. For this, see here, I have used group Y function. Group Y function, why we need it? If you have the data from the more than one column and you want to collaborate that one, for example, a student has 5 subjects. Student ID, subject 1, subject 2, subject 3, subject 4, and subject 5. I want to check out the result of this student. For this, I want to calculate the result of the student. So what I will do, I will group by with the name of student ID, and on the basis of data, we will group all the number and we will calculate the mean out of that. So group Y is basically combining the results from the number of column on the basis of one ID on the basis of we are grouping it. So similarly, we are getting the group by command here. So SNS bar plot is called here. So bar plot will provided you. So this is the bar plot. We are providing these figures with the help of group Y. It will count it out all the columns with respect to that particular value. So we can find out the number of stalls visited. So we are having the 4 categories, and under the 4 categories, it is showing the number of patients that is visited in that particular stall. So these are the 3 graphs, and we have more on. We are just working on some other point of plots that is under the statistical part also. So see, we are having plotting some more histogram, and again for this health score and the drop NA. And there is one more graph that I'm looking for, that is the box plot. Box plot graph, and the box plot graph, this is the box plot. So when you see on this, it is not a simple graph, it is a statistical box. So see, there is a box, this is the boundary, it is the average area covered here. This center line is the mean value, and this is the minimum and maximum, that is the, and other entries after this line and below this line are the outliers. This is the significance of this box plot. So it will provide you the mean, median, mode, average value, range, area, all available under this. So for this, we just have the data frame. We just have the healthcare ID, number of stall visited, and the function we call here the box plot. SNS is the library, cborn library dot box plot. This is the function, and under this we have to define the X and Y variables, and the box will be plotted. So under this, so one more thing. We have title, X label, and Y label, and we have X tick here. We have rotated at the range of 45. See, there is a tilted text here. Why this is tilted? Just because we have done some rotation here in the x tick, rotation is equal to 5. We have tilted that text into the rotation. So this is particular the number of things that we have discussed under the Python for the healthcare analytics project. We have analytics, the number of things that we can use in the Python. We have seen the graphs, we have seen the number of statistics that we can perform. And one thing I want to inform the organizer that I would like to conclude my session earlier because of this short meeting that we have just called. So by 3, I want to close the session. So this is the most of the thing that we have covered under this session because I was told to cover the statistical part in the Python. So maximum thing that we can implement using it, we are doing here. We have done with this code. I will share you the complete data set that I have with this Jupyter notebook. And I have prepared one of these slide for the some basic tools for the research that we can use. I can also share that one. Just wait. So I'm open to questions under this project if anyone want to ask. Uh, Ma'am, if anyone want to ask any questions, am I audible, ma'am? If anyone wants to question from that project that just I have discussed or the healthcare analytics part, so I'm open to that one. So if need any guidance later on under this, that I will also able to help that one.
All the participants are requested to ask the queries in the chat box. If someone has any doubt in the data set or the implementation work, they can share their queries in the chat box. Ma'am is here to answer all the queries. Ma'am, one thing I want to ask,
Hanji, ma'am.
can we use some alternative rather than the sklearn library?
Yes, ma'am, we can use the NumPy pandas. It can cover all the basic function. We have statistical, SciPy, SumPy libraries. We can do all the calculations. We can do plot all the graphs. We have, it is not required. sklearn is for the logistic regression that I have used one. So we can have other libraries we can do with the NumPy pandas, no problem in that.
And if we are working for image segmentation, then
For image segmentation, if you are using machine learning or deep learning, then we need to think if you are going with the deep learning, then TensorFlow is the best option in that. You can use the deep learning models and basic libraries that we can use like UNet. We can have number of libraries for this. ImageNet is there, VGJ is there, AlexaNet, GoogleNet, DenseNet. So we can use with this transfer learning approach. It will be very fast and easier one as well.
ma'am, someone is asking a question in the chat box. Are you able to read the message?
How to identify the suitable regression model? So it depends. If you have a linear problem, then you have a linear regression. If you have a problem with the non-linear options, then you need to go for the logistic regression as well. Otherwise, we have a classification problem. Prediction problem, we have only regression something. So if you have a linear based problem, then we have different aspect. If you have a non-linear, then we need to go with the logistic regression. It is the first type.
All the participants, please share your queries in the chat box. Ma'am, we can wait for 2 minutes so that if someone wants to ask a query, they can write in the chat box.
Up to 3, I'm here, ma'am. After that, I have to leave because I have some important meetings.
Yeah, ma'am.
हेलो मैम
सर आपने जो क्वेश्चन पूछा है टाइप ऑफ टेस्ट so sir we know that we have a two type of data set like we need to go for the categorical approach or the numerical one. So similarly we do have some multivariate bivariate or univariate. On the basis of that even we have to check the biasness. So it is a normally distributed, not normally distributed. So we, on the basis of that, we can find out which test will be. If you have two dependent the samples, when go with the t-test. Otherwise, you can, if you have multiple, then you go with the ANOVA as well. So you need to check out your data. I can't say that this particular problem can be solved by this or this will be dot. We need to find out. Categorical data, we can go with the t-test.
Greetings, madam. Hello.
हाँ जी सर, हाँ जी.
Greetings. Hello.
Hello. हाँ जी सर.
Yeah. Please, I want to thank you for your presentation. It's very nice, and it's an area which I strongly hold. I consider very important to study. But I don't know if you can please help us by sharing your slide and other relevant documents that may aid one effectively exploring this area as well.
Sure, sir, I will provide you everything. And if you have any problem, just send the doubts with the merchant, sir. I will also curate answer that.
Thank you, ma'am.
Anything else, ma'am?
No, ma'am. I think all the queries are answered. So can we end this session, ma'am?
Yes, ma'am. Yes.
Thank you so much, ma'am, for the session. And all the participants, I want to inform you that this was our first day and the second session. And tomorrow also we will start both the session, morning and evening session at the same time, which is written in the flyer. So now, for now, we will end the session. And thank you so much, Dr. Upinder.
Thank you so much, sir. Thank you, ma'am.